friends, welcome to Gallant IAS Geography. Today we're going to deal with a conventional, very important conventional topic from geography, which is quite often asked by UPSC in almost all of its examinations. Today we're going to learn about planetary winds and pressure belts. These questions relating to planetary winds and pressure belts are asked by UPSC in several of its examinations, including civil service examination. So that increases the importance for this subject in your examination. So our strategy to learn this would be to learn it from the very basics, to build it block by block. So we'll start naturally from wind. Wind is simply moving air from point A to point B. Now, wind moves from one point to the other point because it moves from high pressure region to low pressure region. And the speed and the velocity with which it moves from point A to high pressure region to low pressure region is characterized by the pressure gradient. Higher the pressure gradient simply means higher the difference between high and low pressure region, higher the force with which wind moves from point A to point B. High pressure belt, high pressure region to low pressure area. Now, what causes this movement, what causes this difference in pressure is basically temperature. There are other factors, but basically it is temperature. Temperature and pressure are inversely related. That means when one goes up, the other must come down. When temperature increases, pressure will come down. When pressure increases, conversely, temperature would be lower in that region. So this is just a small idea. It is not always, this template will not follow in all the cases. There are some exceptions, but this is generally true for all cases. So, in the equator region, where you have intense insolation, intense solar radiation, you have higher temperature and the air is much hotter. What that means is, higher temperature means lower pressure. You might have noticed that smoke rising up. Hot air rises up into the troposphere. And that principle is also followed here. As the heat goes up, it becomes much lower in pressure. That means wind from higher pressure regions are drawn into the low pressure area. That forms a movement of air, that forms a column of wind. Now, there is another idea of divergence and convergence of wind. As the name suggests, converging winds are winds which come together at a single point. Now, in this diagram, air is moving from high pressure region to low pressure region, and this is not the edge of the world. There are other points beyond this region which might have a high pressure area, and from that high pressure area, wind is actually flowing towards that low pressure area. Now therefore they are converging on a low pressure region. Now what happens when converging winds collide on the point of low pressure? It tends to rise. Convergence leads to rising of the air. And in the opposite, you have divergence of wind. When from the high pressure area, wind is moving out towards all direction, and therefore the wind can be said to be diverging from that point. Now that we have the basics, we'll move to the question of what planetary winds are. Planetary winds are permanent flow of air between pressure belts. You have two pressure belts here, and the wind is moving between them. That is planetary winds. These are more or less permanent. And pressure belts are a zone which is characterized as either low or high. So, as we have said, if this one is a low pressure belt, this one is a low pressure belt, this one is high, and therefore wind will move from high pressure region to low pressure area. This is the planetary winds. And these pressure belts are found around the earth. And we can have different kinds of pressure belts, either low or high, as we go up from equator. So we learn one by one. The first one is equatorial low pressure belts. Equatorial low pressure belts are found within 5 degrees north and south of the equatorial region. It is a point of convergence. As we have said, low pressure regions are points of convergence. Here, winds from high pressure, subtropical high pressure area from the north and subtropical high pressure area in the south converge with each other here, and they tend to rise. This region is also known as Doldrums because of the calm conditions prevailing there. And beyond this, you have subtropical high. This is as low is a point of convergence. High pressure regions are point of divergence. Air is moving out of them, and therefore air is moving up and air is moving down. This is the subtropical high. So from this subtropical high, air is moving up north and air is moving down south. This region is also known as horse latitude, and this is a region of anticyclonic activity. Now, beyond this, about this occupies the region of 30 degrees north and south. Both in the northern hemisphere and the southern hemisphere, we can find subtropical high. Now, beyond that, on the 60 degree latitude, we have temperate low. This temperate low occupies on the 60 degree north and south. Because it is low, it is a point of convergence and it is a point of cyclonic activity. Both from subtropical high, wind is moving up, and from polar high, wind is moving down, and it is converging and rising up. And lastly, we have polar high on the polar extremes, on the north and on the south. Here, because of the high pressure, wind is flowing down towards temperate low in both the hemispheres. These different pressure belts, as we have seen, equatorial low, temperate, subtropical high, temperate low, and polar high. These pressure belts creates a situation where there is a permanent movement of wind between one zone to the other. That creates planetary winds. This is one hemisphere, and similarly, we have a hemisphere down here which follows the same pattern. But this wind does not flow in a straight line. We find it that the winds are deflected towards right in the northern hemisphere and towards left in the southern hemisphere. This happens because of an invisible force called Coriolis Force, which acts upon the moving air. This force is generated by the rotation of the earth. Remember, it is not the revolution of the earth, it is the rotation of the earth on its axis that generates Coriolis Force, which deflects air moving in the northern hemisphere to the right and air moving in the southern hemisphere to the left. So, how it play out is from the equatorial low, from the subtropical high, air is moving down towards the equatorial low. We have learned that. So, conventional wisdom will say that the air should move like this. But actually, because of the Coriolis force, the air moves like this, in a slightly slanted manner. So, if you look at it, it seems like the air is originating from east. And therefore, we call it trade winds or easterly trade winds in the subtropical high. Similarly, from the subtropical high, air is moving towards the temperate low. And it is not moving in a straight line. Rather, it is deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. So, it would look something like this. It is deflected towards the right. And from this from this vantage point, it seems like the air is originating from west. So we call them westerlies. And similarly, we have westerlies from polar high. Both of them are converging towards the temperate low, and they are rising up. And then similarly, in the northern top and the southern side also, at the extreme end, you have polar high, where the air is descending, and it is seems to be originated from east, and we call it polar easterly. That's all about trade winds, and all the phenomena and forces acting upon them. Hope you understood what planetary winds are basically. If you have any doubt, make sure that you go back to the beginning and re-watch this session. Thanks for watching. We'll see you soon.